Hello everybody, welcome back to my channel. This is Ryan over at High Carb Regenerator, and I got asked by about I don't know how many people to do the last part of this video, so let us take off. If you haven't seen the first part of this video, I will link it in a card up in the corner.
Which particle are the triglycerides reduced? And the answer is all, but most dramatically in the VLDL particle. So VLDL particles look a little bit like this. They're full of triglycerides and cholesterol esters inside a lipid monolayer here, coated with proteins.
And some of the people didn't quite understand what was going on the last time. So what they found was that they were finding that the protein was causing a lot of diseases in these mice and rats and whatever else that they were testing. And they found that if they basically starved them out, that a lot of these diseases would go away. But they also found that a very high carbohydrate diet would have the exact same effect. It didn't really have much to do with the surgery, even though he kept going on and on about the surgeries. It had more to do with the fact that we can't handle high protein at all, really. And it's the same to the body as, you know, like it's just so hard for the body to digest. And by the way, protein uses more water consumption than any other macronutrient as well. So basically they were finding that you were healthier on a high carb, low protein, low fat diet than you were on a starvation diet.
Which dictate function. So the first experiment we did was to take VLDL particles purified from an animal on a protein-free diet or a normal diet, inject them into another animal, and see which one cleared out of circulation faster. And dramatically the result was VLDL particles from the protein-free diet cleared faster. Okay. So we went on then to ask what could be the mechanism underlying that. We know it's something intrinsic to the particle. So we looked at some of the genes expressing these proteins which determine function, and we were particularly interested in this ApoA5. People with an ApoA5 deficiency are severely hypertriglyceridemic. So what we found was an elevation upon protein restriction, both on the mRNA and the protein level, and this is suggestive of part of the mechanism driving this reduction in triglycerides. So we did what mouse geneticists do. We got a mouse model, which is normal with ApoA5 or lacks the ApoA5 gene. And you can see that on
that undoes a lot of the stuff that McDougall says, so that triglycerides are significantly different from somebody who eats a lot of protein than somebody who doesn't. Because he's always going on and on about if you eat fruit, you have high triglycerides. The reason for that is when you eat low fat, your body finally starts dumping all the fat that it's been holding on to, and there's triglycerides in your system. I don't understand why he can't see that, but who knows?
On a complete diet, that ApoA5 knockout mice are severely hypertriglyceridemic. When we put them on protein-free diet, they're still severely hypertriglyceridemic. They do gain some benefit. So this says that at least half of the benefit of protein-free diet on this particular phenotype depends on ApoA5. Okay, what about the rest of it? Where do the triglycerides go? So one clue is the discovery back in 2009 by 3 groups that adult humans actually have active brown adipose tissue. And cold exposure is the best way to activate this tissue. Of course, we knew that babies had it, mice have it, but it wasn't clear that adult humans had it. And you can see here, using a labeled glucose in a cold...
This is why the whole Wim Hof thing took off, is because of the brown tissue. You know, actually, thermogenesis or whatever was used by a lot of bodybuilders as well. They would go freeze them. So actually, I don't know if it still exists, but there was actually cold sculpting as well. I don't know if that still exists.
Person, it's here in the rib cage and around the axial skeleton. Under thermoneutral conditions like we are now, your brown adipose tissue is not activated. So mice also have it, and it's between their shoulder blades, the so-called interscapular brown adipose, and it's known to be activated by cold exposure, where it actually prefers triglycerides. That's the energy substrate used to drive heat. It's also activated by exercise. Interestingly, excess calorie intake will activate brown adipose.
If you haven't done cold exposure to a really um, a certain level, you've never felt this before probably. So I used to go jump into, actually last year, even at this time, I was maybe not this late, I think up to Thanksgiving, but I would jump into Lake Erie even when it was like 40 degrees. And that brown adipose tissue, it starts activating. It is the strangest thing I have ever felt in my life. You get so hot in the reason it's where it's at, the reason it's, in the locations that it's at is because it protects vital organs. But when it activates, it gets so hot. I was so hot, I couldn't even believe it. I was sweating. This happened every time too. And supposedly, if you keep doing this, you'll activate all your brown adipose, and adipose is fat, by the way. And then you'll start growing more all over the body, and it's easier to control, and it digests better, and not digest, but it removes itself from the body more. Anyways, but it was crazy. I was in a 40-degree lake, waves. There was, ice in it probably in a couple weeks, and I was sweating. This is why I'm actually confused as to how people get hypothermia when they fall off those boats like crab fishing and stuff like that. I was so hot. I couldn't even I could not even understand what was happening, and it happened every single time.
Adipose, and recently it was shown to be activated by protein restriction. So we confirmed that in our paradigm that 1 week on a protein-free diet, you activate this interscapular brown adipose tissue. You can see the dark color is the increase in mitochondria, which are being used then to burn the substrate and create heat. And we confirm this on the level of gene expression and protein. Here, this is the uncoupling protein 1, which is elevated upon a protein-free diet. And in terms of the timing, by 3 days, this is not fully activated, but at the end of the week, you can see that this process is fully activated. Then we asked the question, okay, these mice lose a lot of weight. I showed you that. And we house our animals at 22 degrees, which is relatively cold for a mouse. So we asked, are these animals simply cold? So to do that, what we do is we put them in their thermoneutrality zone where they don't have to expend any excess energy to generate heat, typically via brown adipose. Nonetheless, even at 30 degrees, we can see an activation of brown adipose tissue, increase in the protein level of UCP1 here, and most importantly, they still lose a significant amount of fat mass independent of temperature. So we interpret this to say that the brown adipose tissue is activated not to generate heat per se. They're already warm here. This is not non-shivering thermogenesis. What they seem to be doing is dissipating excess energy. So now the question is that energy coming from triglycerides, glucose, some other substrate? So we did a very simple experiment. We took mice on a complete or protein-free diet for 1 week, as previously, and we injected radiolabeled triglycerides in the context of a VLDL particle or radiolabeled glucose. And then we looked at the amount of radioactivity that collected in these tissues in the brown adipose. And you can see a highly significant increase in triglyceride uptake and a moderately significant increase in glucose. However, you also notice that this tissue is much smaller. Everything shrinks, particularly the adipose tissues on a protein-free diet. So when we correct for that difference in weight, we get quite a different picture.
You can see the significant difference, and that's crazy how much different it is in just a week.
What we see is that triglyceride uptake is still highly significant, but we lose the significance on glucose. Okay, so I've described two different mechanisms, one involving the VLDL particle composition, one involving activation of brown adipose tissue, which can lower triglycerides. What about the glucose? So here's the reduction in fasting glucose after 1 week on a protein-free diet. First experiment showed that if we inject glucose and follow it in...
That's confusing. Now, there's so many functions going on when you are on a keto diet now because you're killing yourself, basically. But you're also storing more triglycerides. It's a hot mess all the way around. Oops. What are the odds?
It's no different depending on diet. And when we look at all of the other tissues in the mouse, besides the brown adipose, you can see here by the colorimetric that there's no difference in uptake. So the mice don't appear to be uptaking any more glucose in any one particular tissue. Okay, so what's happening then? In the fasted state, glucose is coming mostly from the liver. And so we asked, is basal hepatic glucose production reduced? And in fact, we found
Everybody's felt that. If you've gone and exercised and all of a sudden your liver starts hurting and you're bent over and you're like, I can't believe this, what's happening? And they tell you to drink like a Mountain Dew like they used to back in the day. That means your liver ran out of sugar.
found a significant decrease. These are preliminary data. You can see there are only 3 mice, but we're actively trying to repeat this with more animals. And when we put them on an insulin clamp, so we're further decreasing hepatic glucose production by providing insulin into the system, we see that the mice respond even more, the protein-free mice respond even more than the control mice. So both of these are suggestive that the hepatic glucose production is reduced in the protein-free state. So that can be from 2 different contributions. One would be lysis of glycogen, your stored form of glucose in the liver. The other could be through a reduction in de novo synthesis of glucose. And I'll just present briefly data on the
De novo lipogenesis is when the body turns sugar into fat.
latter. If we give substrates for gluconeogenesis, pyruvate, glycerol, or
But he's saying something different. So it must be turning glucose into something.
animals on a complete diet are able to turn that into glucose. Animals on a protein-free diet have a blunted capacity. So the take-home is the reason a mouse eating a diet high in carbohydrate but without protein has lower blood glucose is because the liver is producing less glucose. Why is that the case? So this is our model, wrapping up the mechanistic part. Here's the mouse on a diet which is, in our experimental setup, 0 protein, so it's mostly carbohydrates, a little bit of fat. I didn't show you any data, but we're fairly certain that the
That's like almost the starch solution right there.
sensing is going on in the
90%
brain.
carbs,
We can talk about the
10% fat.
amino acid sensing pathways at another
Actually,
time.
he doesn't even include 10%
This
fat.
clearly leads to a state of adipose tissue lipolysis, where they're releasing triglycerides or free fatty acids. That's why they're losing the weight. Where do these triglycerides go? Well, they're broken down in circulation into fatty acids and glycerol. The fatty acids go to the liver, where they're packaged into VLDL particles, back into triglycerides, and they're exported in circulation, and they're taken up preferentially by this activated brown adipose tissue. Our interpretation, again, is simply to dispel of excess energy. What about the glycerol? And we think this is the key.
It's weird to me because this video exists and yet he still goes on and on and on about the triglycerides.
To the protein-free diet, this is really what ties things together. Glycerol, as I showed before, is a substrate, one of the major substrates for glucose production. We think that this is going to the liver and driving glucose production, and that's why they're releasing triglycerides. That's what they're looking for, is a substrate. Why? Because the other substrate would be amino acids, and that's what they're trying to spare. So that's our interpretation here of why drive lipolysis. You don't need the fatty acid, you're just burning it. You need the glycerol as a substrate for glucose. The body needs glucose at all times.
So basically it's just burning all of its fat to get glucose out of it. That's a crazy system. That's why all the food you see out in nature and everybody's like, well, I went hunting, but honestly, can you really go hunt something with all you have? You can't make tools. You cannot make tools. It's not possible. With these hands. Could you do it? Maybe a chicken. I don't know. But how would you process it?
And that results then, combined with this reduction in the hepatic gluconeogenic capacity, we think, and we don't know the mechanism of that yet, we think that is the complete mechanism of protein sparing. That's the metabolic logic as we understand it. Okay, nice, rodents. Does it work in people? Do the same mechanisms, are they conserved in people? I can show briefly this paper here, interesting study on 12 healthy and 7 type 1 diabetics, 0% protein diet, carbohydrate replacement, very much like our paradigm for 10 days. And they found that the key result is that protein-free diet reduces the rate of glucose appearance. So that matches our mechanism very well. In a study with Luigi.
You're only supposed to have something like 5 grams in your blood system at all time. And that is why the Randall cycle is so dangerous, because it traps the glucose in the blood system.
Fontana, who was here at the conference the last time I presented, we did a study together. It was 4 to 6 weeks of a fairly low protein diet in males before prostatectomy surgery. And what we found in these patients on the protein restriction, they had reduced triglycerides and an elevation of this ApoA5 protein in their VLDL particles. So we think that these mechanisms are in fact conserved. And this is something I'd like to bring to your attention if you haven't heard of it before, because I'd heard of it in passing, but I really hadn't studied it until recently. And this is the work of Walter Kempner in the 1940s. He was trained in the Warburg lab in Germany and then emigrated to America, where he had a clinic at Duke University. And his treatment was of metastatic hypertension, and this was before antihypertensive drugs. He had his patients in the ward, and he was apparently highly rigorous about their diet. And the whole therapy was based on rice, fruits, and sugar. So it was
I can't believe this is at Harvard, of all places.
Normal calorie diet. I'm just giving
the start of the agenda.
Example of 2,000 kcal a day, 5% protein calories, all from rice. And then to get the rest of the calories, he added carbohydrate. It was by design low fat and particularly low salt. And it had amazing efficacy, I have to say. And I don't use that word lightly. I've read his old papers, and it was really extraordinary, the results he obtained, not just against hypertension, but also obesity, cardiovascular disease. Like we hear with fasting, it was pleiotropic beneficial effects. But the difference here was actually very well documented in hundreds of patients, and you can go back and read these papers and reinterpret it as potentially involving a protein-restricted diet. Okay.
Potentially. It's 5% protein. He told everybody that he was reducing protein.
We also found that...
Is this dude a lawyer now, too?
It's not easily translatable. He had to keep his patients in the ward. They hated the diet. It's monotonous. It's awful. So how can we translate it? What I've been suggesting is that reduced protein intake is the key. So how much protein do we actually eat? And how does that map up against what I showed you in the mice? And lastly, I'll just briefly address the question of which protein source, plant versus animal. So how much do people eat? Well, this is a study of a rather large number of Americans, and omnivores who eat both plant and animal have about 15% calories from protein. Lacto-ovo vegetarians, which is less people, this is thousands, hundreds of those in the database, about 12. Very few vegans in the database, about 10%. So if we map that onto the USDA acceptable macronutrient distribution range, they all are down here. And in fact, humans, free-range humans, eat a very narrow range of protein, and it's around here. Okay. So next we asked, is there difference?
That is completely different than what everybody's talking about on the hunter-gatherers. I mean, if you are nothing but eating animal, all your diet would be is protein. So obviously that's not true.
Between what the amino acid composition of what the vegans are eating versus what the omnivores are eating, who eat a lot of meat. And this is now going to the USDA database of ingredients that contain protein and doing an amino acid analysis. And all this is meant to show is that there are differences in amino acids between dairy and cereal grains, for instance. So that's not terribly surprising. And if we look here at the individual amino acids in animal versus plant, this is before we correct for protein, total protein. Obviously, animal sources have higher protein. When we correct, they're actually rather similar, but there are still significant differences in a few amino acids. Okay. Then we asked, okay, there are a few differences, but is what people actually eat different? And this was the most surprising result. I couldn't resist showing you this. It's not yet published, but if we now correct for the amount of protein in these ingredients and simply look at their amino acid composition, again, between omnivores and vegans, there are no significant differences in the amino acid composition of what they eat. So this was quite a surprise to me, but I think what it said...
I am going to cut this out and probably put that at the beginning, maybe. Man, do I get a lot of DMs about this, and I could just show them this.
Is that amino acid composition, whatever differences between proteins or high, low protein, is not caused by intrinsic differences in the type of protein. Okay. Lastly then, where do the mice land? Well, that's normal rodent chow. It's quite high in protein. We talked about longevity in the 4 to 6% range. And of course, I've been sharing data on 1 week of metabolic benefits at 0%. So we did a simple experiment. How much protein is optimal for a mouse? We went from 18% down to 0, and we looked at a few biomarkers, weight change, around 10%, glucose, again, around 10%. Insulin is more dynamic. Even by a drop from 18 to 14, you already see a benefit. So it's interesting, depends what you look at. So we did.
I know when they did the study in the China study, I think it was over 20%, the animals would get cancer, under 5% they wouldn't.
An unbiased approach using either metabolites or transcripts. And what you can see here is that 18, 14, and 10 all cluster in both data sets, whereas 6, 4, 6, 2, and 0 separate freely. So there's something around between 10 and 6 which is triggering this effect. And interestingly, I'll share that the top pathways activated or repressed are PPAR signaling, fatty acid degradation, and AMPK signaling. This is the signature of fasting in the liver. So these animals, again, are eating a high-calorie diet, low protein, and they appear on the level of gene expression to be in the fasted state. Okay, very briefly, the last question. Animal, plant protein. Is there a difference? Everything I've shown you says no. At the low end of protein intake, and that's key. I'm not talking about high protein intake. I'm not talking about excess red meat consumption. That's a different issue, which I'd be happy to discuss. At the low end, 10% or below, is there a difference between animal and plant? We would predict not, but we don't know. We've been using synthetic amino acid diet. So Mike MacArthur, who is a very talented student in the lab, put these diets together, starting with a 4% protein base with these ingredients, this fat, and then he layered on animal protein using beef, chicken, or pork, or turkey, or plant protein using these ingredients at 6, 10, or 18% total protein. And I'll just show you this last data slide. Whether it was plant or animal protein, the major factor that affected the difference in liver weight was the total protein amount, not the source. So this was what we predicted. And the same with the glucose. The plant and the animal at 60% are the same. So these are the take-homes, I hope.
So basically, vegan protein isn't inferior, is what he's saying, which you hear a lot. You know, they hear about the bioavailability of certain proteins, and how could you know that? Everybody's going to digest it differently.
That I've stimulated from this talk. In mice, low protein intake below 10% of their calories triggers improvements in lipid and glucose homeostasis. We discussed some of the mechanisms underlying there. They're conserved between humans and mice. And there's a possibility, although subject to debate, that a ad libitum feeding of a low protein diet where you don't have to worry about your total calorie intake could be more advantageous under certain circumstances. I also pointed
the lawyer talk
out that the mechanism appears to overlap with fasting. So I suppose you could say that low protein mimics fasting in a way we don't quite yet understand. And finally, at the low end of the protein intake spectrum, the source of the protein doesn't matter. You can eat a little bit of meat, a little bit of plant, you're going to get the same effects. So I'll leave you with this.
Why bother eating the animal? And on top of the fact, that stuff is getting expensive, boy. You know, I do the DoorDash thing. I mentioned that in every video, I feel like now. But I don't pay for this stuff, obviously. But when I go shopping, I'm like, my goodness, man. That stuff is getting up there. By the way, food processing plant 103 or something like that burned down 2 days ago. It's weird. It just must be some kind of coincidence. In the last 100 years, no food processing plants have burned down and not been able to be stopped from burning down. But this year, I don't know what's happening. 103 of them, just, gone. It's just weird, Food prices going up. I don't know. All coincidences, I'm sure.
This thought, in the U.S., this is the new mandated nutrition facts, and you'll see they have percentages for the macronutrients and some of the micronutrients. These generally you want to make sure you get enough of, your vitamins. The fat, you want to limit what you're intaking. Same with the sodium and the cholesterol and the carbohydrates and the simple sugars. But you'll often see, although we do have guidelines on what these percentages are, you'll often see they'll list the grams of protein, but they're not really giving a recommendation one way or the other, whether you should have more or less. So next time you look at a label and you think about what you're eating, you might ask yourself, am I eating enough protein or perhaps too much? So I'd like to thank two people in particular. Mike is this wonderful student at my lab.
I mean, they make it so...
Who did all of the diet and bioinformatic work. And Umberto is the one who really didn't believe this phenotype when he first saw it and went to figure out the mechanisms underlying that.
There it is. I did it. I reviewed the second part. Hopefully you liked it. Hopefully you stayed for the whole thing. And hopefully you now see just how unbeneficial keto or carnivore is for you. But maybe you don't. Anyway, likes, comments, questions, all that good stuff down below. Talk to you in the next video.